Hi, and welcome to part 3 of the video series for section 5.1. This will be the last part of the video series for section 5.1. We're going to be talking about what's known as the reference number. So let me give you a definition. So we're going to let t be a real number. The reference number and we're going to call this t bar. So a little t with a line over the top of it. That's our indication this is a reference number. So the reference number t bar associated with t is the shortest distance and because we're talking distance, our reference number has to be positive. So if we're ever doing any problems and it's like, what's the reference number to this value t? Your value has to be a positive value. If it's not positive, then your answer is incorrect at that point. So a reference number, the reference number t bar associated with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. So as you're writing this down, it sounds super confusing. You got a lot of t's and t bars and unit circle and distances and x-axis. The easiest way to think about this is, again, let's assume that the unit circle was a sidewalk in a park. And let's assume then that the x-axis was a street where a bus went back and forth. All the reference number is talking about is, let's say you go for a walk along this unit circle and all of a sudden you realize it's time to get home and you need to find the shortest distance to get to the next bus stop. Well, if you're at this point on the unit circle, the reference number, which is the distance, would be this green line here. How short is the distance from where you're at to the x-axis, or from this sidewalk to get to the street to where the bus is going to pick you up if the bus is running along the x-axis? So that's all this verbiage is really talking about. Let's look at a few examples here. So again, if you haven't got done writing this, go ahead and pause it real quick, finish writing it, and then you can come back and join back up. All right, so our examples, we want to find the reference number. So the first one we have is when t is equal to 5 pi over 6. So if we give ourselves a little sketch of the unit circle, 5 pi over 6 is where? It's over here in quadrant 2. So what this question is asking is, what is the distance from that point down to the x-axis, the blue line? Well, that would be where t bar is equal to pi over 6. It's that last little 1/6 that we need to get to in order to get down to the x-axis. Example 2. If t is equal to 7 pi over 4. So again, if we give ourselves a little sketch, it's positive, so we're going counterclockwise around the circle. 7 pi over 4 puts us where? Well, it puts us down here in quadrant 4. So then what is the distance from this point back to the x-axis? Well, it's just where t bar is equal to pi over 4. Again, you can see these are both positive. They're both talking about distance back to the x-axis, so they both have a positive value. Let's try another example. This case, go ahead and try to solve it yourself. So as we did in video 2, I'll give you the example. Go ahead and pause it, try to figure it out, and then come on back to check your answer. So what if t is equal to minus 2 pi over 3? So go ahead, pause, and come on back. Okay. So the first thing is this minus sign. So hopefully you caught that, and that tells us what? That tells us that we're going clockwise around the unit circle. So that means instead of going in the normal fashion, we come back this way, and 2 pi over 3 then would put us where? It'd put us over here in quadrant 3. So our reference number is this value here to get back to the x-axis. So in that case, our t bar would be pi over 3. So hopefully you're starting to notice a pattern here, which is what? When we had 5 pi over 6, our reference number was pi over 6. When we had 7 pi over 4, our reference number was what? Pi over 4. When we had negative 2 pi over 3, so even though it was negative, our reference number was what? It was still pi over 3. So if we're talking thirds, it's thirds. If it's fourths, it's fourths, and so on. Where it gets a little tricky, and to be honest with you, this is more of a couple homework problems. You're not really going to see this throughout the semester. You won't see it on any of my exams. I don't ever recall seeing it on the final exam, so you probably won't see it there. But they like to give you this one here. If t is equal to 5.80. So, where is this falling on the unit circle? Where's our pi? We got rid of the radians. Well, let's draw our unit circle. We know this was 0. At this point over here, this value is what? Pi. And pi is what? Pi is about 3.14. If we kept going around to here, this is what? This is 2 pi, which is roughly, what, 6.28. So we know that t is 5.80 ends up somewhere in the bottom half of this circle. And if we wanted to figure out this point here, it would be halfway between these guys. And so the 5.80 ends up somewhere around here. Again, think of this as a sidewalk. And if it's 6.28 units around, 6.28 miles or 6.28 yards or whatever it could be, 5.80 gets us around to this point. So this distance in here then would be what? Well, to get back to the x-axis is 2 pi, but you have to subtract off this guy here, 5.80. So that would be the answer. 2 pi minus 5.80 is what the length of that little portion is there. So again, it's more, you're going to need this for your homework problems, not so much for any of the exams in here. All right, so last part of section 5.1 is where we're using reference numbers to find terminal points. And to be honest with you, we kind of already did that a little bit. I sort of jumped you guys ahead, but it'll just make this a little bit easier, hopefully. So using reference numbers, to find terminal points. So if we're given t equals something and we want to find that terminal point, we can do the following. First is find t bar, our reference number. Second, we're going to find the terminal point. We'll call this one Q, with values a, b determined by t bar. So all number 2 is saying is if my reference point is pi over 6, then I'm going to use square root of 3 over 2 and a half. That's what number 2 is doing. So 3 says that the terminal point is the point plus or minus a plus or minus b where the signs are chosen according to the quadrant in which t, our terminal point, lies. So again, if you're writing the notes, you need to pause it for a minute, that's fine. Just hit play once you're done. We'll do a couple examples and you guys will be finished up here. All right, so let's look at these examples. Find the terminal point for the given t. So the first one we have, t is equal to 5 pi over 6. So 5 pi over 6, we know that ends up in quadrant 2. So that means x is negative, y is positive. Our reference number, because it's 5 pi over 6, means the reference number is pi over 6. The coordinates for pi over 6 are square root of 3 over 2 and a half. And because we're in quadrant 2, that means our x value is negative, the y value is positive. So the terminal point for 5 pi over 6 is minus square root of 3 over 2 and positive 1/2. So try this one. T is equal to 7 pi over 4. Go ahead and pause, give it a try, hit play once you're done. All right, so our reference number here, 7 pi over 4, we just figured this out a minute ago, the reference number is pi over 4. 7 pi over 4 puts us down in quadrant 4. So that means our x is positive and our y is negative. For pi over 4, it's always going to be square root of 2 over 2, square root of 2 over 2. And x is positive, y is negative. So the terminal point for 7 pi over 4 is just square root of 2 over 2 and minus square root of 2 over 2. All right, last example. What if we have something like t is equal to 29 pi over 6. This is obviously nothing that we've learned from our unit circle. We know at the 6 that our terminal point is going to be pi over 6. But the question then becomes, what quadrant does this land in, so that I know, if I know that pi over 6 is square root of 3 over 2 and 1/2, but I don't know what signs have to go on here because it's dependent on this quadrant. So I need to rewrite this guy, ideally taking out as many 2 pi's as I can. That way, it'll tell me how many times I'm getting around the circle a full time around. So 29 pi over 6, so I want to go back to the next one. So this is like 24 pi over 6. And if I have 24 pi, that means I still have 5 pi left. So 24 pi over 6 plus 5 pi over 6 gives me 29 pi over 6. So I haven't changed this value, I just rewrote how it looks. Well, 24 pi over 6 is what? 24 divided by 6 is 4. So that means this first part is 4 pi, and then plus 5 pi over 6. So now, if I want to figure out what quadrant this is in, I first have to go 4 pi, which is 1, 2, 3, 4. So 2 full times around the circle, and then I still have to go 5 pi over 6, which puts me where? Over here in quadrant 2. And in quadrant 2, I know that my values for x and y are negative and positive. So that means when my terminal point is 29 pi over 6, using the reference number, I know that the terminal point is equal to negative square root of 3 over 2 and positive 1/2. That ends section 5.1. Good luck, and we'll see you in class.